Let's walk through activity number 10 together, and like we said in class, this one is optional, but especially for those of you who still feel a little bit rusty about derivative calculation or maybe learning calculus for the first time, I highly encourage you to go over this problems yourself. So this problem, if you look at it, it's quite obvious. It's multiplication between two functions, so we definitely start with product rule. So we end up with sine x prime multiply ln x plus sine x multiplied by the derivative of ln x. And this is what I have as cosine x times ln x plus cosine of x multiplied by 1 over x. I don't need any further calculation step, but also this is the least amount of writing I need you to do. Okay, so the next problem, I have whatever happened in the parentheses definitely has to be calculated first, and then what's afterwards is ln of. Okay, it's not ln times. Be careful about the difference. So because it's ln of a function, that is to say it must be a composite function. So we are going to use chain rule. Well, what I hope you've already remembered based on our discussion about logarithmic function is that ln of f of x takes derivative. That structure is f prime of x over f of x. Therefore, you can directly use it, but of course you could have used chain rule and carry out the calculation one step at a time. So in this particular case, following the rule, we end up with whatever comes behind the ln structure, take derivative over itself. So we end up with 2x plus 4, and then we end up with x squared plus 4s. Again, this is the least amount of writing I need you to do. So the next problem, if you look at it, I have a numerator, I have a denominator. My last step is division. So the least I need to do is to start my writing and apply the basic structure of my product, my quotient rule. So derivative of the numerator multiply the denominator minus the numerator times the derivative of the denominator, and then divided by ln of ln x, and then have it squared. So once you work this out, the next thing for you to do is to identify the two terms here. You could have write them on the side, which I think might be a better idea. So what you end up with is technically just a duplication of what you have here with those two terms clarified. Okay, so let's try to fill in those two blanks. So first thing, it's actually a simpler problem, is the derivative of this. It's again derivative of ln of something, so it's whatever comes behind the first ln over itself. So it is 1 over x over ln x. So I can fill it in here. It's 1 over x times ln x. The second part of it is to calculate what's the derivative of cosine of 3x takes derivative. Well, this is clearly 3x comes first and then apply cosine to it. So apply cosine to a function, it's definitely composition. When you try to work on function composition, you will be using chain rule. The outside layer is cosine, so chain rule says you differentiate that. Right, so and then you substitute the inside layer of it, and then you take derivative of the inside layer. So what you end up with is negative sine 3x multiplied by 3. So you can put your answer back in here. Again, this is the least amount of writing I need you to do. Okay, you could have directly applied your chain rule if you wanted to, but you should again give me the basic structure. So continue our discussion here. Well, those are relatively straightforward. It's an exponential function. The derivative is just that. But of course, if you want to take higher order derivatives, which we technically practiced on already, don't forget this is a base of 2, and the ln2 is a constant. So it's mathematically equivalent to that. So it's 2 to the x times ln2 times ln2, and it would make my life significantly better if I had simplified it. And therefore I'm going to move on to my third derivative, which is to take my second derivative, and then one more time. It's again the same idea. This is my function, this is a constant, so I'm going to take derivative of the first layer, right, and then multiply by the coefficient that's left out. You could have simplified your problem and end up with that. Well, I do want you to pay extra attention realizing the fact that the exponential structure comes first. So negative 2 of x is mathematically equivalent to 2 to the x with a negative outside. It is not negative 2 to the x. My base will never be a negative number. Therefore, it's mathematically equivalent to that, which is negative 2x times ln of 2. For this problem, if you look at the structure, well, you can either take advantage of the formulation I've already provided, which technically came from chain rule, or you realize it's kind of like similar to 7 to the x, where the x is changed to its chain rule. So what you do is you take derivative of the outside layer. The outside layer is 7 to the power of x, and then you multiply by the derivative of what was squeezed in by the x, which means ln x. So what you end up with is squeezing the inside layer, and then what you have 7 ln x times 1 over x. Again, what I did here essentially is use chain rule. Sorry, my bad. I was a little bit sloppy with my calculation. Let me just take what I said back. I forget to multiply ln 7 and ln 7. I'm very sorry about that. Okay, continue my same line of thinking. It's technically 10 to the x with the x changed into sine x times ln of x plus 1. So my calculation, again, is to use chain rule. It's 10 to derivative of the outside layer, which is 10 to the x, and ln 10. And then you substitute the inside layer, which is this. And also you multiply by the derivative of the inside layer, which is that. So you want to carry out what exactly is the derivative of this structure. Well, in order to work that out, you may realize that this is a multiplication of two functions. So you're going to use product rule. So it's ln of sine x times ln of x plus 1, and then times ln 10 times, okay, so we take the derivative of out one part, and then the other part, and then sine x and ln of x plus 1 takes derivative, and then, my bad, it's 10 sine x times ln of x plus 1 times ln 10 times, okay, let's carry out the derivative. It's cosine x times ln of x plus 1 plus sine x, and then we times the derivative of ln of something. Ln of something, we have done it repeatedly, right? It's a derivative of the numerator over the denominator. So the derivative of the denominator is x plus 1 takes derivative, which is x1 plus derivative over x plus 1. But because x plus 1 takes derivative is so straightforward, so you could have realized it directly already, so it is 1 over that. Okay, so this is what we end up with as the final answer. So we have two more problems. Let's find the derivative of that. Always, as usual, you think about the last step of calculation. It's two functions multiplied together. So you are going to use chain rule. So you have sine of 2x prime times ln 5 cosine of x multiplied by sine of 2x times log 5 of cosine of x takes prime. So the derivative, you have sine of 2x. For sine of 2x, it's a composite function, so you have cosine of 2x, but then we have an inside layer which 2x substituted into it, and multiply by the derivative of the inside layer, and then log 5 of cosine of x, and then plus sine of 2x. For the log function, you either directly refer to formulation, or you realize it's log 5 of something, so it's an exponential function composited with cosine x. The composite function, the outside layer log 5 of x, has a derivative, which looks like what comes behind the log 5, and then ln 5, and then multiply by whatever comes behind the derivative inside layer. You substitute the inside layer into the derivative of outside layer. So this is cosine of 2x multiply 2 multiply log 5 of cosine x, and then I have sine 2x, and then 1 over cosine x times ln 5 times negative sine of x. So this is our final answer. Okay, So the last step we have here, so this problem we have ln of ln of ln, so that's 3 log functions, one squeezed into another. So that what we have here is definitely going to be a composite function. So you look through it, the last step is log 2 of x. So the derivative is log. So what we have is the derivative of log 2 of x. The derivative is whatever comes behind log 2, and then ln2, and multiply by the derivative inside there. So squeeze the log function inside, what comes behind log inside, and also takes the derivative of that. Okay, so I structure things out based on help of chain rule. And then I try to find out the second case. We have ln of log 3x multiplied by ln2. And then what we have here is a log function. Log function takes derivative is, again, the same structure. It's 1 over whatever comes behind it multiplied by the derivative of the whole thing. Right, so what I end up with 1 over ln of log 3x times ln2, 1 over log 3x, and then 1 over x times ln3, which is our final answer.